Hey, this video we're going to talk about vectors in the plane. And normally, if we were in my classroom, I would show you a video from Despicable Me or a clip where Vector introduces himself and his name, his official like bad guy name. And he says, I'm vector. It's a mathematical quantity. It's an arrow with both direction and magnitude. It's one of my favorite videos ever. So you should look it up. It's awesome. So the Despicable Me clip, vector introduction. So, anyways, it's cute. So it's a direct line segment or an arrow with both direction and magnitude. So think of it as just a line segment like this. So magnitude, that's a weird word. Magnitude is just the length of the vector. And then we have what we call the tail of the vector, which is in this case at the origin, because this vector is in component is sitting at the origin, and its head is at the end. And in this case, we'll call that point the point AB. And we write a vector with these little arrow kind of brackets instead of parentheses. So the ordered pair AB is here at the end of the vector. And so we name the vector AB because that's where it stops. So AB would be the ordered pair for the point where it ends. So this vector, when we write it A, B like this in with the arrowed ordered pairs, is what we call component form. Its components A and B represent the ordered pair that where the vector stops. Okay, so we're going to go through a couple of examples. I'm going to give you a vector. We're going to calculate its magnitude, which is its length. And then we're also going to calculate something that's called its directional angle. So we talked about it having both direction and magnitude. Direction meaning where is it going, and then magnitude being how long is it. So I'm going to erase all of this stuff. If we have the vector 3, 4, the vector 3, 4 would land at the point 3, 4. Let's say that's the point 3, 4 right there. That means that we went 3 to the right and up 4, like so. This would be the point 3, 4 if we were talking about ordered pairs. Okay, so how about the magnitude, which is the length? Well, think of this as just a right triangle, a squared plus b squared equals c squared. C squared, which would, or c, which would be the hypotenuse, is the length of our little arrow segment here. So if I use my Pythagorean theorem, 3 squared plus 4 squared equals 6c squared, and take the square root, that's exactly what you're doing to find the length of any vector, just using that Pythagorean theorem to solve. So then to find the direction angle, so an arrow with both direction and magnitude, right? Direction. So that's this angle right here, right? I have the opposite side of the triangle, which is the 4, and the adjacent side of the triangle, which is a 3. So that would be tangent. And then to find the angle that goes with that ratio, we use our inverse tangent. So is that always going to work? Yes. Will we always be able to use the tangent or the inverse tangent with the y over the x? Yes. Excuse me. So then we calculate that using a calculator, and we get 53.13 degrees. Make sure that your calculator is in degrees for this lesson. You want to have your answers in degrees, not radians. Okay, so then the question will be given to you in a little bit different format. They're going to give you the magnitude and the direction angle, and you're going to come up with the component form. So how does that look? If I have the magnitude and the direction angle to find the to find the x coordinate of the component form, I multiply the magnitude times the cosine. So that v with the like what looks like absolute value bars is the magnitude of the vector. And then obviously that right there is the direction angle that they're giving you. So magnitude times the cosine of their angle, magnitude times the sine of the angle. So if they're giving me the magnitude of some vector u, which is 18, and the direction angle is 25, I just plug them in. If I'm at a 25-degree direction angle, you might think for yourself for a second, where will this land at 25 degrees? So think of your angles on your unit circle like you normally would. So we move up into the first quadrant with 25-degree angle. So it's 18 times the cosine of 25 degrees, and then 18 times the sine of 25 degrees. And that's our component form. And so you just use a calculator to find that, and you get 16.314, and you get 7.607. So that makes sense. That's in the first quadrant. 16 to the right, 16 up 7 would land us in the first quadrant. And then you'll need to be able to go the other direction. So what if they give you the component form like -3, 9? So we talked about the fact that, so here's our vector, -3 to the left 3, up 9, yeah, that's where it would end. And so our magnitude of, let's call this vector P. So our magnitude of vector P is just the square root of -3 squared plus 9 squared, which is the square root of 90. We're going to go ahead and leave it in square root form. If you're doing something that asks for its decimal approximation, that's when you'd use a calculator to approximate the square root of 90 at 9.46 or whatever it is. And then for our magnitude or our direction angle, that's our direction angle, right? Lands in second quadrant. We use the inverse tangent of the y value divided by the x value. Now, when I type this into my calculator gives me an angle of -71.57 degrees. So why would my calculator give me a -71.57 degrees? That angle is right here in the fourth quadrant. I don't need a fourth quadrant angle. I need a second quadrant angle. That's how the inverse functions work. They're going to give you a first quadrant and a fourth quadrant for tangent and cosine. I'm sorry, tangent and sine. For cosine, you'll get a first or a second quadrant. So if you need a quadrant, so it's giving me a fourth quadrant angle, I need, according to my picture, according to the component form of my vector, I need a second quadrant angle. So how do I get from down here to up there? You add 180 degrees. So adding 180 degrees to our -71.57 gives me 108.43 degrees. And that is the second quadrant angle that I need. Okay, so if they give me the magnitude of A, which is 5, and the direction angle of A, which is 117 degrees, and ask me to find -4A. they're going to ask for the magnitude, the direction, angle, and the component form of negative 4a. So the component form of negative 4a looks like negative 4 times the component form of a. The component form of a would be 5 times the cosine of 117, 5 times the sine of 117. Oops, sorry. Right? And then you get these numbers and you multiply the negative 4 times them. So you get 9.080 and negative 17.820. So this is a negative 2.27, and then I multiply the negative 4 times it and I get the 9. This is a negative, or is a positive 4.45, and I multiply the negative 4 to get the 17. Okay, so originally our A vector was here, right? This is A. And then multiplying that by a negative 4 makes it longer, but it also reflects it upside down. So 4A would be like right here, right? Negative 4A. So that makes, sorry, not there. Here. There. Sorry, it reflects it. Okay, so here's negative 4a. So when I go, this is my component form of negative 4a. If I need my magnitude, if I need my magnitude of negative 4a, you can either calculate the magnitude of this by doing this squared plus that squared and the square root, or you can just take positive 4. We're going to take magnitude is length. So the negative, we use the absolute value of that. And so it would just be 4, and then the magnitude of A, which was 5. So you should get 20. Now, if you did negative, or you did 9.08080 squared plus negative 17.820 squared, and you took the square root of that, you're going to get something really close to 20. So if you did it the long way, that's fine. So again, I'm using the absolute value because negative 4 is not a length. 4 is the length. Negative means it reflected it down into this quadrant. So 4, because it's length of the vector. And so then we would do the, for the angle, we would do the inverse tangent of the negative 17.820 divided by the 9.080, and you get an angle of negative 67.08. Now that works just fine because it's a fourth quadrant, right? Negative 67 degrees is right there, and that works. You could also add 360 to it. Sorry, that's not the right one. It's 62.99. And if you add 360 to it, you'd get 297. So again, this one we don't have to add 180 to it because it lands in the third or fourth quadrant, right? Negative 67 degree or 63 degrees is backwards into the fourth quadrant. The picture of our 9, negative 17 vector is in the fourth quadrant, so that one is our answer, and it's just fine. Okay, so then you have some word problems. Angela walks 3 miles at an angle of 35 degrees. Then she turns and walks 2 miles at 80 degrees. Finally, Angela turns and walks 6 miles at 155 degrees. Find the magnitude and direction of the resultant when the three vectors are added together. So this is just distance, cosine, angle, direction angle, distance, sine, direction angle. 2 cosine 80 degrees, 2 sine 80 degrees, 6 cosine 155, 6 sine 155. Now, what you're going to do, so all I've done is taken each direction that Angela walked, her distance and her direction angle, and put it in component form for each of the three segments. Then you're going to add the three vectors together. Now, I recommend that you just type it in like this: 3 cosine 35 plus 2 cosine 80 plus 6 cosine 155, and type that in one long calculation. Being sure to close parentheses around each angle, the calculator will give you the open parentheses automatically. So what do we get? We should get negative 2.633. And then when you add those three together, you should get 6.226. So that's our component form of where Angela ends up after walking those three segments. So that's her component form. So let's draw a little picture of what we're talking about. So she walked 35 degrees for 3 miles, and then 2 miles at 80 degrees, and then 6 miles at 155 degrees, something like that. And so her angle, her vector, her resultant vector, right, when she's done, goes to left 2.633, up 6.226. So it's something like that. See this picture. Okay, so then we calculate the magnitude of Angela's resultant vector, V, and we do the negative 2.633 squared plus 6.226 squared, and you get 6.76 miles. So this vector, she's now 6 miles away from where she started. And then we use our inverse tangent of the y value, the 6.226, divided by the negative 2.633, and we get a negative 67. So this is one I thought I looked at earlier. So again, negative 67 is going to be down here in the fourth quadrant. We don't want a fourth quadrant angle. We want a second quadrant angle. So again, we add 180 to our 67 degree angle, and we get 112.92, which is the second quadrant angle, which is what we want. The negative 67 is a fourth quadrant angle. We don't want that. Okay. All right, that's it. Thank you.